G'day Year 7, how you going? We're continuing looking at angles. Today we're looking at angles at a point and vertically opposite angles. Now, angles at a point are basically, if you have a point that's common and then lines coming out either in any direction, all of those angles that are created around that point are going to create a full revolution, aren't they? Okay, and we know a full revolution is equal to 360 degrees. So any sum of angles that are formed around a single point will add to 360 degrees, and that's an important thing to know. Vertically opposite angles are when we have a crisscross. So as soon as you see lines like this, where you have a crisscross, you're going to see vertically opposite angles, okay? And these angles that are across from each other are vertically opposite. Now, vertically opposite doesn't actually always have to be vertical. I know that's a bit confusing, but if you just change your perspective, they'll become vertical again. So we can also have these two angles here being vertically opposite. If we were just to look from the perspective of the right, okay, so if I was to look at this like this, then they would appear vertical. And so we just use the term vertically opposite. Even if it's horizontally opposite, it's the same thing. So we just say vertically opposite. And those angles are always equal. We're going to talk a little bit about why that is, but that's an important thing to know. So firstly, angles at a point, sum to 360 degrees. Vertically opposite angles are equal. And this one we already know, angles on a straight line are supplementary. I've just made a typo here. Supplementary, they add to 180 degrees, okay? So we're going to look at a few questions. We're going to write what our answer is, and we're going to show our working and show our reasoning. So the way that we show our working and our reasoning is important. So make sure you're listening, and then you copy that when you do your work yourself. Okay, first of all, we have a question here. We've got to find the size of STU. Okay, so angle STU is going to be equal. Now, if they all add up to 360, we can write 360 minus the other angles, and that will, what's left over will give us the size of that angle. So 360 minus 135 and minus 114. Now, we're actually going to give a reason to why we know that to be the case. Now, we're going to do this a bit more in the future, writing out our reasons in brackets, okay? And the reason is angles at a point. Okay, add to 360. So the reason why I can write that equation is because of the reason in the brackets, because angles at a point add to 360 degrees. Okay, once I have that reason, I can continue doing my working out to find my angle. I can use a calculator. 360 minus 135 minus 114 equals 111 degrees. Okay, so we used the 360 minus the other two angles to find the remainder, which gives us the angle STU. For part B here, we have a few more angles to consider. So we've got angle STU, and again, it's going to be 360 minus because they're all at a point. But we've got to remember that this square symbol means 90. So minus 90, minus 158, and minus 63. And our reason is angles at a point add to 360. Okay, so we're providing a verbal reason or a written reason why we can do that calculation. That's going to become more important as we continue with this topic. Okay, so again, I get my calculator out, and this time it's going to be minus 90, minus 158, and then minus 63. And I get my answer is 49 degrees. So it's an acute angle this time. Okay, so we can use this. Maybe that was right. We can use this reason to find out missing angles that we needed there. Okay, now for this one, we've got to look at what the relationship between FGH, okay, so here's FGH, which is this angle here, and the angle that we're missing. Okay, so sometimes I like to draw a little arc to show which angle I'm talking about so I don't get confused. Okay, so here angle FGH equals, and we know it's going to be equal 72 degrees because my reason is they are vertically opposite. And we know from before that vertically opposite angles are equal. So I know it's going to be the same size as the vertically opposite angle. Even though it's across from it, it's horizontal, we still say vertically opposite. For B, FGH again is here, and we have another angle. So we can just say FGH equals 143 degrees. And the answer is because they're vertically opposite. Okay, that one's easier because we don't have to do any calculations. We don't have to do 360 minus or anything like that. We can just say that they're going to be equal because of the reason that they're vertically opposite. Okay, so find the value of the pronumerals given reasons. Okay, it's a similar thing here. Now, we've got to be careful. We've got to be careful. These angles X and 143 are not vertically opposite because if you look, those lines bend. We've got bendy lines. What we need to have vertically opposite angles is two straight lines that meet at a point. Okay, so you can see that JF continues straight through the point G, IH continues straight through the point G. There's no changing of angles. Whereas here, the angles are changing. So we can't use the vertically opposite thing. We've got to use, okay, angle X is going to be 360 degrees minus all the other angles. We've got to use our angle at a point reason. So 90 minus 143 minus 52. And our reason is angles at a point add to 360. Okay, so when you're doing geometry, you actually have to write your reasons in brackets, and the wording is important. You got to use that angles at a point catchphrase. You can't just say whatever you want. It's got to be really precise. So here, we just pop this in our calculator. Okay, these first parts are the same. 143 minus 52, and we get our angle X is 75. So this one's slightly different because rather than giving, there's no letters given to the points, we're just given a pronumeral that we've got to find for the angle size. So X equals, and our reason is given in brackets. And then for part B, again, we can't use vertically opposite angles because we have, oh, actually, this is a really clever question, If we look at this whole angle here, okay, then that is vertically opposite A because we have straight lines here, and then we're just splitting up the lines together. So we can say A equals 62 plus 15. Okay, and the reason why is it's vertically opposite, those two angles put together. So we're using sort of all sorts of things here, adjacent angles that when we add them together makes the greater angle. Okay, so 62 plus 15 equals the angle that's vertically opposite to A. And then we can just simply simplify this by saying, putting these together. So we get 77 degrees is what angle A is equal to. Okay, so you see we've got working out and we've got our reason written in brackets. It's important that you write those when it's necessary. If you used angles at a point, you got to write that reason down. If you use vertically opposite, you got to write that reason down. Okay, I hope you enjoyed the video and good luck with the work, and I'll catch you later.